All right. Hi, everybody. So we're going to talk very briefly about a eccentricity of Python. This is just a little example about how typeless languages work. So in Python specifically, I'm going to show you how this works. So I've got a very simple program here. It only does three things. It asks the user to input two variables, which I've called var1 and var2. It's going to add those two variables together, and then it's going to print them out to the line. It's going to print out the result of adding them together, and it's going to print out whether or not that sum is greater than the first variable and whether or not the sum is greater than the second variable. And you'll see why this matters in just a minute. So I'm going to run this, and I'm going to type my first variable in as 1. My second variable is 3. So now, when it adds them together, when it does the sum, you can see here that the sum it printed was 13. But that's not 13. This is not 13, and I'll explain why in just a second. So if we come down here, we see 13 is greater than 1, and it says that is true. And it says 13 is greater than 3, and it says that's false. So, how is that possible? That is because what you are seeing here, this is not 13. This is not the number 13. This is a character array. And the character array has the characters 1 and 3 in its 0 index and its 1 index. So, because Python is a typeless language, that means if you do not tell Python what data type your variables are, then Python has to guess. And sometimes, like in this case, you can see Python guesses wrong. Now, it will guess consistently. If I run this program 10 times, it's never going to give me a different output than this. But anytime you use the input command in Python, if you do not tell Python what type this variable is, anything that comes in through the input is treated as a character array. Okay? So, when I add two character arrays together, what actually happens, as you can see here, is it appends. It takes one character array and it sticks the other one onto the back of it. Because that's how character array addition plus. That's how adding two character arrays works in Python. And that is expected behavior. So again, this is not the number 13. What you input was the character 1, not the number 1. You input the character 1 and the character 3, and then I added those two characters together, and I got this string, or this character array, 1, 3. That is not 13. So when I get down here and I do these comparisons, the reason that these two results look wrong or look different is because it is comparing the character array 1, 3 to the character array 1. Character arrays and strings are considered less than another character array if, when you get to the end of one and there's only null characters after that, there's nothing else, if you're just as if you were sorting something alphabetically, like book titles, nothing comes before something. So the fact that this or something comes before nothing, rather. So the fact that this character array of 1 does not have a value after this means that because this character array has any character at all in the at index 1, because remember strings and arrays start at index 0. Because the array 1, 3 has a character at index 1, that means it is greater than the character array of 1 null. When we get to the second comparison, since both of these character arrays, 1, 3, and 3, both have a value in the 0 index at that first position in that character array, it's going to ask, is the character 1 greater than the character 3? And it says no, and so it stops. It doesn't check the rest of the string because it doesn't need to. So, if you do not tell Python what type your variables are, either when you do math on them here, or when you actually input them here, Python will always consider them to be character arrays, and you're going to get some weird, unexpected behavior. So if I cast these variables as integers when I bring them in my input up here, now when I run this, Python knows that these are integers, so when I ask it to add them, it's actually going to treat them as numbers. And then the rest of this should actually do what we expect it to do. So now if I type in 1 and 3, the sum is 4. 4 is greater than both 1 and 3. This is really, really, really important for you to remember for this entire semester. If you do not tell Python what type your input is or what type of variable is, it will always treat it as a question mark if it's a variable, or it will treat it as a character array if it is input. And it will never tell you that it's doing this. This is supposed to be helpful and nice in that if you have an integer and a double, or a double and a float, or you have different kinds of types, or in this case, if I have a character 1 and I try to put it into, if I cast it to an integer like I'm doing here, Python will try to put this character array into a box of shape integer. And in this case, it was able to do that. If I run this again and I type in Q, it's going to die because I have told it, please accept a character array from the console, which it's fine with. I typed in Q, but when I tried to put that character array Q into the box that is shaped like an int, it says, I can't do that, and it dies. So, please remember to explicitly cast your variables either when you bring them in, when you declare them, or when you do math on them. It's probably easier to cast them once, the first time you see them, than it is to cast them every single time you want to do math on them. So, let me see if I can give you another example. If I don't cast these when I bring them in, which, remember, means Python says these are character arrays. So I'm asking the console, or Zybooks, if I input it up there, for 2 character arrays, which I'm calling var1 and var2. If I then cast the result of that addition to an integer, what number do you think I'm going to get? So this is where it gets really funny. So now if I run this, I'm going to say 1, 3. Now look, the sum, it says, it prints out this variable, 1, 3. But is that a number? Well, it says here that we have a type error. So I asked it to print the sum, the first variable, and then a comparison between the sum and the first variable. So, because the first variable, we have not told Python what type this variable is. But because we got it from input, the first variable is a character array. So we asked Python, please tell me whether this sum, which is an integer, is greater than or equal to this character array. And Python says, I don't know what to do with that. So in here in my comparison, since I have not cast variable 1 as an integer when I brought it in, I could cast it in line right here when I do that comparison. 1, 3. Okay? So now it correctly evaluated this first line, but then it basically told me the same thing. On the second line, you asked me to compare this integer, sum, is it greater than or equal to this character array, var2? And it says, I don't know what to do. So I suggest that rather than do inline casting like this, because if you don't assign this value back into var1, you're going to have to do this cast every single time you mention var1. And in that case, like I've done here, it's going to be very easy to forget to do that. Or if you're unlucky and Python doesn't throw a type error because you had like the very first thing when we did with the character arrays and it just stuck them together, like we've done here, remember, this value is still wrong. If I actually sum the numbers 1 and 3 together, I should get 4. But what's happening is inside this parentheses, these are character arrays because they have come from input. So it is adding the character array 1 with the character array 3 and getting the character array 1, 3, which it is then storing in the variable called sum, but it is storing that value as an integer. So this is also wrong. We don't want to do a cast on the result of an addition between two other variable types. We either want to cast them both and then store the result, which you see if I run this again, 1, 1, 3. Now the sum is correct. Now the sum is 4. But again, because var1 and var2 are still character arrays, because we haven't actually stored this value anywhere, when I get here, it's going to go ah. So what I suggest is, first off, name your variables more descriptively. Integer 1 and integer 2 instead of just generic variable, because like when I'm reading this down here, what is var, right? I'll be able to spot this a lot easier if I know what my variables are. So then if I run this, this should still give me the same incorrect output here, but I'll be able to read this a little easier. All right, what's it complaining about? Oh, just have a loose floating number here. So 1, 3. All right, so now it's telling me, hey, variable 1 is not defined, which means, yep, I didn't replace it everywhere. I didn't refactor correctly. Still trying to demonstrate this. See, this is how easy it is to mess this stuff up, so don't fret it. 1, 3. All right, now my sum is 4. That looks good. But what's it complaining about now? So it says, hey, I have a type error. Less than equals is not supported between an integer and a string. Character array, string, same thing. So it says I cannot compare, I cannot do this comparison between an integer and a string. So this will tell me in order, right? So it says sum compared to integer 1. And it says I cannot compare an integer and a string. And these are going to be in order. So the integer is my sum, and the string is integer 1. So now, by naming my variables a little smarter, Python or PyCharm's error will actually basically tell me what I need to do. I have a variable named integer 1, but Python thinks it's a string. So this will prompt me to go back to wherever I have declared integer 1 and cast it as an integer, because that's what it's supposed to be. And then if I run this again, the second one will do the same thing. So now if I run this, now all 3 of my variables are integers, and this should behave sanely. Okay, so let's do another example here. I'm going to make a new variable, and I'm going to call this definitely a number. 1. And I'm going to set that equal to 4. And if I could spell, whatever, I'll just call this a number. This is 4. And this is another number, and I'm going to set that one equal to 5. So I'm going to reuse my variable from up there, which the variable has been declared as an integer. So whatever I put in here could be anything. So if I reassign this variable as a number plus another number, let's see what happens. I'm going to comment this stuff out. Right? It's going to ask me for these two. All right. Maybe I should actually print this. Huh? Let's print that. So what I type in here doesn't matter because these are going to get override. Now, I have typed in a number is 4 and another number is 5. I said add those two together and store that value in sum, which is a variable. Now, I have not told Python that this variable is an integer or a float or a string or anything else. So if I just declare a variable like this, I just make a new variable name and I assign it to some value, Python has to guess what data type it is. And in this case, it got it right. So I'm going to try something else. I'm going to comment out this stuff up here. And I'm going to run this again. Okay. So I haven't told Python, my variable names really don't matter. I have not told Python that this is a number. This is just a variable that's been assigned a character or a value. It's not even a character. A value of 4. And this one has been assigned a value of 5. Python doesn't, because I haven't told it this is an integer, right? Or this is a float or whatever else. I haven't told it that. But Python has to guess. And in this case, it guessed correctly. So you have to be super careful with this kind of stuff. Because Python, being a typeless language, oftentimes, like in this case, it will get it right. But certain times, it won't. So you need to be careful to either cast your values when you assign them to a new variable, or cast them when they come in from input. Because the input function will always return a string. So if you don't want your variable to be a string, you need to tell Python this is an integer, this is a number, this is a float, this is a whatever else, an array, a list, doesn't matter. If you don't want your input to be a string, you have to tell Python that. So that should be it for now. I will maybe find another example of where Python does something that doesn't make a lot of sense, but I don't remember, so let's find out together. If I cast this value as a string, is it going to throw a type error, or is it just going to do this addition? Let's see. So if I run this, look there, unsupported type. So this gives us a little peek behind the curtain. This says Python tried to add these two things together, and it says I cannot add, I don't know how to do plus for an integer and a string. So that's telling us that Python has interpreted this variable as an integer, even though I haven't told it it is one. And it's interpreted this one as a string because I have told it that it is one. So again, I can do an inline cast here, and even though this value is a string, I can tell Python, please try to make this an integer. And now it does it. So if you run into an error where you're doing basic math, basic comparisons, and you're getting nonsense answers, or you're falling out of your if statement or your else block when you don't think you should be, double check by printing out the values that are stored in your variables after you assign them to make sure that it's not doing something like I did right at the very beginning, where I added 1 and 3 and got 13. And then when I compared 13 greater than 3, it said false, because it was comparing two strings and not two numbers. That will be important for this week's lab and probably going forward. So remember, always cast your variables when you read them in from input. I would recommend casting them even if you want it to be a string. Just always cast when you bring in from input, and then whenever you declare a variable, a new one, just to be safe, cast it when you assign it a fixed value so that Python doesn't have to guess. And then if you go later to do math or comparisons with it, and it's not the type you were thinking that it should have been, like, see, I have this variable called another number, and then I've cast it to a string, which may be what I wanted to do, which may mean my variable's just not named very well. Or it could mean that I did a whoopsie, and I meant to cast this as an integer, and I actually cast it as a string, which means when I go to do stuff with it later, Python's going to yell at me, say, hey, I can't do that. I tried to add a number and another number, and that one's a string. And again, because I've named my variables in a smart way rather than just some ultra shorthand, I say, oh, another number shouldn't be a string. Another number should be a number. So now I can go back here and go, oh, well, I've cast this as a string. It should be a number. And now it does math. All right. Try to keep this short.